and welcome to Physical Science in the AM. I am Joel Shandelka. And hot dog, we got an out of sight class. We're going to just zip through this. And so buckle up and feel the G's. Anyways, I'm going to just pause to update the attendance, and then we'll talk about this before we try the problems I just handed out. All right. First, just a little trip down memory lane here with moles of gas. Off screen. Good. We talked about last week. So what we were talking about is any gas. And it doesn't matter if it's carbon dioxide, oxygen, whatever. If it's at the standard temperature and pressure, and we're going to assume every question I give this here is at standard. It takes up 22.4 liters of mole. So this makes life a lot easier. Unlike grams and moles, which is different for every mole. You have to look that up on periodic. This time we use just 22 every time, 22.4. So we looked at a few conversion examples, one step. If you have moles, you want to get rid of moles, you put the 22.4 liters on the top. You must show your units. This is very repetitive, as in, you see this is the same work. Every time you let your calculator do the work. If the numbers are on the top of a fraction, mole. And we saw the opposite. If you start with volume, that's measured in liters. You want to get rid of liters, so you put the 22.4 liters on the bottom every time. 1 mole on the top. It's repetitive. So I think with 3 and 3, 6 examples, you can quickly figure out it's not going to be any different. I don't care what the gas. So then we extended this a bit, and this goes back to stuff we've been learning for the last little while. Two-step conversion. And basically every two-step conversion that I'm going to give you in the next little while involves finding moles with the first bracket. Then you've got to know what your answer is. So always start with what you're given that's not a fraction, grams. I got to get rid of grams. I use the periodic table. I got moles. And then the second thing, what I want, is how many liters. So I put that on the top to get rid of moles with my second. You will notice the only similarity between all of these is that you've got moles with the first bracket if you start cut. And then the second bracket you get rid of. That's similar for each one. We tried a variety. Could have been particles, could have been grams as well as liters, stuff like this. It might not involve liters at all. We did a few of these examples, and no surprise, I just handed out some. And the first bit is just strictly convert the following volumes at STP, so 22.4, into moles. That means 1 mole is what you want, and the 22.4 liters is going to be on the bottom for those three. It's going to be repetitive. You're going to practice with those. Then the second thing, moles to liters. Again, more practice. And it's just one fraction. You want the liters 22.4 on the top of the bracket. You're going to show it as a flat fraction. You want to get rid of moles, so you put the 1 mole on the bottom. Oh, my magic pen now. The second side is two-step, multi-step conversions. So we're finding mass, it's finding grams, and it's very similar to the examples that we have. What is volumes? That's finding liters at STP. Find the volumes, find the liters if you're given molecules. That's where you use 6.02 times 10 to the 23 things in moles. How many molecules? How many molecules in grams? So the for example, the last one doesn't use. I'm just noticing something about the last one. It doesn't even use it. Here's what I noticed is that when I was typing this up, it should have been E, and I have ED. Hey, not that a big deal. Just know to do it. work away. I'm giving you time. This is taken up in class. You're doing this right now. Okay. I'm just taking up the first side because that doesn't take too long. Converting volumes, liters, into moles. I set it up. They're all the same calculation each time. And I remember just doing this with somebody else. 3 digits in, 3 digits out. 0. Was it 446, I think? Oh, meters are gone. Oh, what am I doing here? Wrong time. Okay. Meters are gone. And we're left with the full mark answer is moles and N2O4. This one here. Can you guys help me out with this? I think it's 0.4 or 4.46 times 10 to the minus 3, or what is it? Or how did you guys look? Madeline, I always like your numbers. Minus 4? What did you have? So I'm going to put both answers. 4.46, right? Times 10 to the minus 4 is what you said? That's going to be mole CCl4. This is the exact same answer as 0.0004446. That's what you had? Either answer is 100% correct. This is sort of the borderline. After this, I wouldn't want to write all those French words. Sort of. Any more than that. But if you do write a number with a lot of French zeros, and I'm going to just jot this down for sure. Make it easy for you and me. If you were to write down something like this, use spaces to group them in 3 so that I can easily see. I would prefer, say, minus 1, 2, 3, 4, 5, 6, 7, 8. 10 to the minus 8, 3.8, 10 to the minus 8. Instead of that, you can see why it saves at the time. Anyway. The last one of these, 7.5 divided by 22.4. I'm not sure what it is. Oh, yeah. So these are all multiplying by 22.4, repetitive calculations. So I'm going to just ask people for answers, but if you dispute, let me know. By the way, each answer should have 3 significant digits, because that's the smallest amount. Even on C, there's 4 digits in 250.0, but there's still 3 in 22.4. So I'm going to just ask from, say, Christian's table, what is the A answer? 54.7, and no dispute about ground. Okay, that's liters of CO2. Somebody from the back table there. I'm going to write that above here. 1,697.2, right? Oh, 0.92. Okay. The moot point, because that's more than we need. Because we need 1, 2, 3 digits there. Moles of cancel. 3 digits and 22.4. So with this one, we have 2 options. I need to round to 3 significant front digits. So if I round 1697, that 7's telling me what? Boost this up, round it up, right? And when I round up that, it's like a domino, it pushes the next number up. It's going to be 17. I'm going to write this down. One, I keep getting the wrong color. What am I doing? Anyways, so I've got 1700. Now I don't need a space in here. Liters of Cl2. I would accept that answer, but this is ambiguous. I put a space there, that doesn't mean it's. When I look at this answer, I don't know if this is 2 significant digits, 3 significant digits, or 4 significant. but we do know from our rounding, it was actually 3. So the best answer is 1.70 to show that there's 3 significant digits. Scientific notation should only show significant. And that's 10 to that 1, 2, 3. Okay, you can see all two words. Okay. So, cool on that? It's the back zeros before a decimal that are ambiguous. If a 0 is behind a decimal, it's important. It's significant. Just like C, 250 decimal 0. That's 4 significant digits. That counts the behind it. But we still only have 3 digits in our answer. Not done this one? Okay. Somebody from the backish region in the middle. What do we get for C? Okay. I put that down. 5,600. Okay, you got what? 560. I can't hear that. Okay. Okay, and I'm going to use a calculator and just see what we should get. 250 times 22.4. Then it's 5,000. Try it out. Okay. Not a calculator. Not a biggie. And the answer is in liters of O2. This is again ambiguous. Is that 5,600 or 5,600 ish, or is it 5,600? We know it is accurate to that position, right? 3 significant digits. So how do I show that? I'm going to show it with scientific notation, so it's not ambiguous. I'll accept this answer as a full mark one right now because we're using it. But 560 times 10 to the 3,000 position. That's it. It's like this is your best answer. I will give marks. Incidentally, if you know how we heard one answer that was 560. That was a calculator. I would still give you 1 out of 2 because I'm looking for this first. Okay? And if you had 560 instead of, it's just, I would use a calculator this time. You're never going to fail. Show you what. Now these ones here, people were already started on. And the trick is always to get moles with your first bracket. Since I put these in sentences, we can't take that shortcut where we just start inside the type number. So 15.0 liters of O2. And I want to get rid of liters and go to moles with my first bracket. My second bracket, you can figure out what I want to get rid of moles and mass is measured in grams. Every one of these is slightly different, so don't assume everything is the same. Okay? I'll give you some time to run through those. We'll take them up as well. Okay, I worked through these and forgot to start recording. I'll just explain while these guys are working on here what we did. We got rid of liters, first bracket, converted to grams by looking up the mass of 1 mole of O2. This question. Got rid of grams, converted to moles, first bracket. We wanted volume, that's measured in liters, so we used our going forward. C. We were given molecules and we wanted to use volume. So we use 6.02 times 10 to the 23 molecules on the bottom there to cancel out the molecules. Got moles. Cancel moles with the next bracket. Leave that one. Okay, my calculator gives me 13283, 13,283.7, blah, blah, blah. But I only need significant digits 3. So here's what my calculator gave me. I'll do this 13283.7 and blah, blah. Okay. I need to complete it though with 3 significant digits, so I need to round to that spot. I'm going to go 1, 3, and push it up. 3, 0, 0 to hold the placement. That is liters of, and forgot to put the N2 here. Anyway, you could, that one's not ambiguous now. Like, it's only showing 1333 significant digits, but I will put it in that too. Okay. How many molecules do you want for the large number of molecules? 55 liters. Start with the single item that's not a fraction. Oxygen. I need to get rid of liters. It's a gas, so 22.4. I won't put it. And to get rid of moles here and go to molecules, I'm going to put 602 times 10 to the 23 molecules. So 55 divided by 22.4. Where was it? Divide by 22.4 times 6.02. That's 2 digits, yep. 1.48. Rounded properly here. Times 10 to the 24 molecules of oxygen. Lastly, how many molecules again? But this one's in grams. I'm going to start with 55 grams. It's not going to involve liters at all, even though it's a gas. Oxygen again. I purposefully use the same number, 55 liters followed by 55 grams. In this case, I want to get rid of grams. And oxygen, when I look it up on the periodic table, is 16 times 2, so 32 grams. I want to get to molecules, so it's 6.02 times 23 molecules. And can do that. 55 divided by 32. 1.03. 3 digits, yeah. 10 to the 24. That is in molecules of oxygen. Okay. That ties everything up. Now, reminder about the test tomorrow.